Good evening. Hope everyone is staying safe and well. Well, in this particular video, we would be looking forward for the vector form of Newton's law of gravitation. Now, we are quite known to this part of the equation of Isaac Newton, which we have read in our textbooks in our school days, F equals to g m1m2 whole divided by r squared. I'm not going to go further and explain the components of this particular equation. But what we need to note is that this part of the equation is a scalar quantity. So we can write it as scalar. Now by scalar, what I'm trying to mention is that there is a magnitude, which is this part, but there is no direction. Now when we are trying to represent it in a vector form, we need to take a note of few points. Now to represent this equation in a vector form means that there should be both magnitude as well as direction. Now in order to present a vector, we need to have both a magnitude as well as direction. So for example, if I take a vector v, for example, and I want to represent it in the vector form, so I have to take the magnitude, which is often represented by this modulus sign, multiplied by vector, which is a unit vector, followed by a hat sign. This is the unit vector. Now, for example, I take two masses. Why I would taking these examples, it would soon come clear. Now, if I take one mass, say m1, which is separated by some distance, and here is another mass which is m2. Both of them are separated by distance r. Now there is a convention of writing force in vector form. So the convention is we write F to represent force and we write two units. The two units are being represented as, say, for convenience, I'm writing it as on and by. Now, what is on and by? What I'm trying to tell you is that force acting on mass 1, which is being pulled or acted by mass 2, right? So, in order to write that, for example, if I write on mass 2, force acting on this ball, that is mass 2, which is being pulled by mass 1, force by mass 1. So in that way we write on and by. On means the force is acting on which body? Either it is this body, by this body, or acting on this body, by this body. So, and the direction, obviously the direction, if you want to write it, is the final minus the initial. So for example, if I write direction, so the direction would be final minus the initial. So I put it as fin minus initial. So it is quite simple and it comes obvious that if I write F21, that is force acting on mass 2 or particle 2, which is being pulled by mass 1. Force, you can remember it in this way, force when it is acting on 2 and it is being pulled by mass 1, on 2 by 1, obviously the you can think in this way that this is on 2 and this is by 1. So the final is m1 or 1 and the initial is m2. So force when it is final minus initial for say for example F21, the direction can be, it is not an equal, just to put it up, for force 21 I can write that the direction would be r. If I take it this 21, it would be r1 minus r2. I put it this part as r1, I put this part as r2, just to represent. This is not the final. We will be coming to the final part again. So when I'm saying that the force is acting on body 2, which is pulled in by body 1, that means the the final part is R1 because it will be pulled by this body 2 is acting on body 1. Say for example, you can take it that this ball would be moving a little bit. So the final objective is this one minus R2. In the same way, when we can write F12, that means the force on and by, remember this part, just on and by, force acting on 1, obviously, force acting on 1, which will be pulled by body 2. In that case, we can write the direction as R2 minus R1. Force acting on body 1, pulled by body 2, that means the initial part will be R2 minus R1. So it is just the reverse. You see, force 2, 1, that is force acting on body 2 pulled by 1, 2, 1 is 1, 2, and 1, 2 is 2, 1. 2, 1 is 1, 2, 1, 2 is 2, 1. Simple, right? So in this way, if we take the force which is acting on body 2, 1, say for example, that means it is being acted on 2 pulled by 1. So let us put it in this way. Force, which is a vector quantity represented by this arrow, 2, 1 equals to G m1 m2 whole divided by r squared, right, multiplied by r, which is the direction. We take it as a unit vector, 1, 2. So obviously this is 2, 1, it would be 1, 2. That means force acting on body 2 pulled by body 1, the final is 1 and pulled by body 2, so R1, 2. In the same way, we can write force 1, 2, that is on and by, that is force acting on body 1 pulled by body 2. It would be simple, G m1, this would be m1 m2 whole divided by r squared, with represented by the unit vector r2, 1. This is 1, 2, it should be 2, 1, right? Now we need to understand one more thing, that what is this R12 and what is this R21. Now just note that when we are representing a vector, which we showed just above, right? The vector is represented by the magnitude and the direction. So in this case, if we just want to write it in this way, say for example, I take R, which is a vector, and we represent this by the magnitude of r multiplied by the unit vector r, right? And then we can have, for example, if we cross multiply it, we can have the unit vector r equals to the magnitude r modulus, you can write it in this way, divided by r, the direction vector, right? So this is the way in which we can use we can find out a unit vector. We have mathematical calculations on that, given a value, how can you find this, that. So I'm not going into those details. Now, for example, this is one part of the equation. Now, if I want to represent this r hat 1, 2 and r2, 1 by the values of real vectors, right? So I want to change it. So this part, let me mark it, this part and this part will be changed because I want to represent it by the full vector. Full vector is what? This one, r equals to the magnitude direction, and from there we deduce r equals to this, right? So let us write the equation once more. What we get from here, this one, f12 and f21, right, this part. So we get f12 and this is the earlier one and this is the final. So we will start with f21. So let me write f21. Yeah, here you go. F21, that is force acting on 2 by 1, will be the same, right? Equals to G m1 m2 whole divided by r squared. And this r f21, that is this one, r12, this would be replaced by this r12 would be on the top, which is a vector, whole divided by r, right? Why? Because this hat r, that is this unit vector, have been represented by this. So if I get this on the top, I obviously have this in the below at the denominator, right? So from there what we can write is this. We can write G m1 m2, and this we multiply and we get it as squared, a cubed, r cubed, and we need to write it by the unit vector r12, that this would be r12. This is a vector, right? So this is the representation of f21. So quite simple, you can understand. Now you can deduce f12 also, nothing to worry about. You write the same, g m1 m2 whole divided by r squared. I am just making the steps for you so that it's easy to understand, multiplied by r21. It's quite a simple formula. You can say 1 2 would be 2 1, again whole divided by r, because hat r is being replaced by this one, the unit vector. So from what we get from here is this. So g m1 m2 divided by r cube multiplied by r21, right? So you see, this is one part of representing the Newton's law. This one on the top, where we get the force acting on 2 and 1. This is 1, force acting 1 and 2, and this is 1. Now what we did is that we converted this unit vector to full vector. We converted this unit vector to full vector, and what we got, f21 we got this part, and f12 we got this part. Now there is a small thing which I would also like to show you, which is a little bit on the graphical side. Let me just quickly draw a small graph for you so that you can understand. I will just show you in a minute. So this is one. Now for example, we get a Cartesian coordinate. Say for example this one, we get a Cartesian coordinate and we get two masses, m1 and m2, and we get a vector which is the force which is operating right from the origin, right? And this is m1, this is m2, so we get this, and I will just show you a label you will be able to understand. So this one is m1, this one is m2. These are 2 point masses, the two particles. This one, the vector is r1, this one is r2. What we are interested is this, the distance r, right? What we are interested is this, the distance. So now what we can do is that we can just represent this in simple form. So we just go by the same convention. We get it as F21, which we already know, force 2 which is acting on 2 pulled by 1, equals to G m1 m2 whole divided by, now what we need to know is that the lower part would be the distance. Now because by formula, say for example, we know this is 2 1, so obviously the distance would be 1 and 2, right? The force acting on 2 pulled by 1, what is the final minus initial? The final is r1 minus r2, and this would be cubed as per the previous one which we have shown, right? So you can see this parallelly. See this parallelly. This one is r cube, m1 m2 remains the same, and what we see over here is this, and this one would be multiplied by r1 minus r2. Obviously it would be r1 minus r2. These are vectors, so we put the arrow signs. In the same way we can take up f12 equals to G m1 m2 whole divided by, this is 1 acting on 2, so the distance would be r2 minus r1 cube, and this would be multiplied by r2 minus r1, and these are the distance from the centers, right? So there you go. What I have shown is here that if you plot the vectors or the masses m1 and m2, which is a vector r1 and r2 acting, and this is being separated by distance, how can you write it in vector form? F2 and F1 are being just replaced by r1 and r2, and these are the difference. Cube remains the same at below. Also, I would like to show you what we did in the previous part, that is the Newton's law of gravitation. F on, I will just summarize what we did. The direction is always final minus inertia. So for F on and by, this is force acting on body 2 pulled by body 1, or acting on body 1 would be force acting on body 2 which is pulled by body 1. So the final is 1 which is being pulled, and on 1 on body 2. Similarly, force 1 and 2 would be R2 minus R1. Representing this in vector form, we get R12 and R21. Also, we know that a vector is represented by magnitude and direction. Hat R, by cross multiplication, we get this. Also, from in the same way, if we can represent this part, that is F21 and 12, we just change those values by representing 1 and 2, and this comes 2. This multiplied becomes cube. This multiplied also becomes cube, which we have shown below this part. So this is one way of showing the vector form of Newton's law of gravitation. This is another form of showing the vector form of Newton's law of gravitation. This is yet another form of showing Newton's law of gravitation. Given 2 points which is being separated by, acted by 2 vectors, R1 and R2, and we need to find out the, the distance between them. So this is the way in which we do it. Lastly, what I would also like to say is that often and on we have seen that there's a negative sign. This is G minus G M1 M2 whole divided by R squared. Now we need to, we get often confused, and I have seen that we need to understand like what exactly is this negative sign all about. Why is this negative sign coming? Now, just to give you an analogy, just to give you a basic analogy, say this is the earth and this is the moon. Just quickly put up some this is the earth and this is the moon, right? Now earth is exerting a force F on moon, right, in this way. Moon is also exerting a force on earth, that is maybe F double dash. Now because it is acting in both the ways, we get this negative sign. This negative sign, don't take it that this negative sign means that it is an integer sign. That means 1 minus 2 or maybe 2 minus 2 or something like that. No, negative sign denotes that gravity is attractive and it is not repulsive. Negative sign denotes that the gravity is attractive. So this minus G, it is always be minus G because each body is exerting force on another body. Similarly, the second body, as we have seen, M1 and M2, they are also exerting force on the second body, and hence the force is negative. The minus sign would come. Also note that gravity by nature, it is attractive, and I would just put it up, it is not repulsive in nature. When we go through general theory of relativity and Gauss's theorem, we will understand more onto this. The nature of gravity, it is attractive. The negative sign denotes that. Also you will find minus 9.8 meter per second squared, which is the small g gravitational acceleration, is also negative in vector form. The reason being that it is simple. If we draw a small graph and if we put an object over here, and if we are accelerating, that object is pulling up in this direction, gravity is always pulling it down. This is why g is minus 9.8 meter per second squared. The nature of gravity, this is something fundamental which we will learn further in expanding the theories of gravity. It is always pulling down. So you are pulling or you are throwing a stone up, right? You are doing a positive work because your force and the stone both are going in this part. so it is a positive work. For gravity, it is negative work, right? So if the force is in this direction, F, and work and the displacement D is in the same direction, it is considered to be positive. That means you are pushing something, it is moving. You are pushing something, it is coming in the opposite direction. Your finger is being moved by the other force, it is considered to be negative. So when you are throwing a stone up, standing here, the stone is going up, you are throwing up, it is a positive work. For gravity of a earth, this is negative, because when you are throwing a stone up, the earth is pulling down, so it is in a different direction, so it is considered to be negative. When a stone is falling down, the earth is pulling down, it is also considered to be a positive work done, because the displacement and the force is in the same direction. For the respect to earth, the throwing of the stone is negative, because it is always pulling down, and that is the reason this part and this part is negative. What we have learned in this part of the video is that how to represent the Newton's forms of gravity in vector form. We have seen different forms of vector. We also have understood that why this part, the F2 and F1, how it works out. Final minus initial is always a formula, so we get the things. Simple thing, if it is F21, it will be 1,2. If it is 1,2, it will be 2,1. You can just take it as a cheat factor. And why this is negative? Because of the repulsive nature of gravity, and that is the reason small g is also negative. That is the gravitational acceleration. Watch out for more videos in this part, which I would be trying to make it. Stay safe and stay happy, and thank you very much for watching my videos.